So you should not be watching this video yet unless you have actually tried these problems and you're just tuning in to check to see if you're correct. Here are your correct answers. If you got them all right, then fast forward to the next section. If you missed something, stick around and listen to my explanations. So if you take a look at this first polynomial, in the top, I pulled out a GCF of 5xy and was left with 3x plus 7. In the bottom, I pulled out a GCF of y squared and was left with 3x squared plus x minus 14. When I then went to do the next line, you might notice down here that there are some y's missing. That's because this y at the top, I canceled out one y at the bottom, and I am left with 5x over y here. Then when I went to factor this bottom part, because we already have this 3x plus 7 up here, I guessed that when I broke up negative 14, the 7 was going to go with the 3. So I tried that, and naturally I checked my inners and my outers, and found that I did get x. Then you cross off your common factors here, and then you're left with 5x over y times x minus 2. In number 8, what I did is on the top, all you can do is pull out a GCF of 3, you're left with x plus 1. In the bottom, all you can do is pull out your GCF of 9x, and you're left with x plus 1. And then these x plus 1s, well, they cancel out. And then if you take a look at the 3 over the 9x, well, that reduces 3/9 reduces to 1/3, so 3 over 9x reduces to 1 over 3x. In number 9, I pulled out my GCF of 12x to the third y to the second. Make sure you don't forget to pull out your variables when you've got variables in common, and I was left with x squared plus 3x minus 10. In the bottom, I pulled out 10xy squared, was left with 3x squared minus 5x minus 2. Then you might notice that these monomials out here, I reduced them. So I reduced 12 over 10 to 6 over 5. I canceled out this x at the bottom to leave me with an x squared at the top, and the y squareds went out completely. And then when I factored this top part, I got x plus 5 times x minus 2, and on the bottom, 3x plus 1 and x minus 2. I then canceled out my x minus 2's because they represent the same number, and was left with 6x squared times x plus 5 over 5 times 3x plus 1. So here are the answers to the next set of problems. Again, pay attention to what's inside the boxes. If you didn't get these answers, then stick around and wait for explanations, and you're welcome to fast forward until you get to the explanation that you need. So taking a look at number 10, there was no GCF on the top, so I just factored that into x plus 2 times x minus 8. Another reason I know my signs are going to be different here is because I have negative 16 at the end. So if the last term is negative, you know your signs are going to be different. The bottom had a GCF of 3, so I had to pull that 3 out. I was left with x squared minus 8x minus 20. Again, I know my signs are going to be different when I go to factor this because I'm getting negative 20 there. I used the top to help me factor the bottom. Since I already knew I had an x plus 2 and an x minus 8, I knew probably an x plus 2 or an x minus 8 was going to be down here. I knew it was x plus 2 because 2 goes into 20 but 8 does not. So I started with x plus 2 and I figured out that the other factor was x minus 10. I then canceled out the x plus 2's, crossing those x plus 2's out to leave me with the x minus 8, and then the 3 times x minus 10 on the bottom. In number 11, I have GCFs again. On the top, I had to pull out a 3x squared to leave me with x squared plus 13x plus 12. On the bottom, I had to pull out x to the third because they both had x to the third in common, leaving me with the binomial x squared minus 144. I factored this further into x plus 12 times x plus 1. And then this was a difference of squares because it's a perfect square minus a perfect square, so the only way to factor that into is x plus 12 times x minus 12. I also, this 3 over x, I went ahead and canceled out the x to the third and the x squared. I took away the x squared. I was left with 1x at the bottom. So that's where that 3 over x comes from. I can then cross out the x plus 12s because those were common, and then I just wrote down what was left, which was 3 times x plus 1 and x times x minus 12, and that's my final answer. Number 12 is one of those weird ones. The top, there is no GCF, but I could factor that into 2x minus 3 times x minus 1. The bottom, you may have not known what to do with this, but x to the fourth is a perfect square. 1 is a perfect square. It's a perfect square minus a perfect square. So that's going to break into a difference of squares, which would give us x squared minus 1 times x squared plus 1. You may have stopped there thinking, oh, I don't have anything in common, but this one right here is still a perfect square minus a perfect square. I could break x squared into x times x. I can break negative 1 into 1 times 1. So this part brought me to these two binomials here. So then I can now cancel out these x plus 1. So this x plus 1 and this x plus 1 goes away, and what I'm left with is the 2x plus 3 on the top, and then the x plus 1 times x squared plus 1. This one cannot factor further, again, because that's addition, not subtraction. So these last two problems are trying to get you to understand the difference between dividing a polynomial by a polynomial and dividing a polynomial by a monomial. So number 13, notice this problem right here is different than all the other ones because look, you're dividing by just one term. So what I just said is this is a polynomial divided by a monomial. If you just have one term at the bottom, then all you have to do is you put the 3xy underneath all of the terms, which is what I did here in the solving part, or the simplifying part, and then you just reduce each fraction separately. And so I was left with 2y minus 4 over x plus 1.